Built-up environment today accounts for close to 39% of carbon emissions. Just like navigation today, getting from point A to point B, you don't realize all the tech that's gone into it. I believe that next 10 to 15 years, it's going to become where the geospatial just becomes a de facto enabler to provide the data, to provide the insights, to provide proper, decision making as far as decarbonization of buildings are concerned.
Hello everyone, and welcome to the very first episode of Problem Solved, a Geoawesome podcast. I'm Muthu, and I'm joined today by my co-host Alex. Every episode, we want to highlight a real-world problem and explore how geospatial technology is solving them. So if you're curious about the real-world impact of geospatial and data and tools, you've come to the right place and to the right podcast. This is our very first episode of our series, and we're going to be kicking things off with a topic of global importance, which is decarbonization of our built environment. Before we get started with the podcast and introduce our guest, I want to give the opportunity to Alex so that he can give us an insight about what the main issue here is.
When we think about sustainability and geospatial, typically we think about satellite imagery and looking at the deforestation problems and so on. But from the perspective of global CO2 emissions, not everyone realized that buildings account for 39% of them. And understanding those emissions, understanding and mapping this challenge is a problem. Typically, we associate that sort of reporting with a very expensive and resource-intensive process, but we want to discuss today that it does not need to be always the case. And with that, I would like to invite and introduce Bobbie Kalra, who is a founder of Magnasoft, and Bobbie will help us explore those pressing issues. Bobbie, thanks for joining us. Maybe could you start with telling those listeners who don't know you a little bit about yourself and about Magnasoft?
Sure. Thank you, Alex and Muthu, for this opportunity. A quick introduction. Magnasoft has been in the geospatial business for over 20 years. I started off as a CAD engineer doing a lot of work in CAD and then moved to geospatial way back in early 2000. And Magnasoft today has done work in over 72 countries. We specialize in geospatial data analysis and asset design. And ESG, environmental social governance, is an emerging market for us. Apart from this, we also focus on telecom, which is fiber and 5G. And also in land mapping and administration, especially on the cadastre side. That's a brief background about myself and the company.
Why ESG reporting is such a big challenge, and how geospatial technologies are uniquely positioned to help solve this problem?
Data. It's all about the data. When it comes to analyzing, the built-up environment, and even for that matter, the greenfield projects, the new real estate developments that are happening, it's very important to analyze information and data, and geospatial provides that platform to enable decision making in terms of analysis and also doing the simulation. Because when we talk about the built-up environment, we talk about dimensions, we talk about surface areas, we talk about conditions of the material. And location plays a very important role as well. So to have all this information on a platform, where a real estate developer or some of the governments and compliance, decisions can be made. Geospatial provides that kind of platform. So it's very important and sort of the heart of the entire system when it comes to planning, operations, and maintenance.
So now let us discuss a little bit how you are sorting out those problems, those challenges within Magnasoft. You've mentioned in our pre-interview mGreen solutions. Could you elaborate a little bit about mGreen and how you're addressing those challenges?
Yeah. So, Alex, as you rightly said, today the built-up environment today accounts for close to 39% of carbon emissions. And in the built-up environment, we talk about the life cycle of the asset, the LCA, right? And when we look at the life cycle of an asset, right from its design and materials and operations, maintenance, and the decommissioning, there's a whole bit of analysis that needs to go into how this building was built, what materials were used in that particular building, what is the as-built status of the building today, and what decisions need to be made in order for us to decarbonize these buildings. And we have been involved in Europe essentially in doing a lot of it started off with us doing just BIM work and building information modeling. We're doing this entire built up environment using all kind of sensors and capturing data. Then we realized that this information was, it's an emerging market. Our clients were still trying to figure out how the data can be used to do, analyze, decarbonization. And it sort of evolved over the last couple of years where keeping the end in mind, understanding what kind of parameters influence decarbonization or decisions on decarbonization, what parameters will help simulate, the building analysis, whether what percentage of the buildings, when you look at the overall at a macro level, what percentage of the buildings need to be sort of decommissioned, what buildings need to be renovated, and what buildings are okay, right? So it was sort of when we started off, it was more of a bottom to top approach, but now with the last couple of years, at least our solution mGreen has evolved, keeping the end in mind, keeping some of these standards, be it BREEAM or LEED or the NEN 2767, which are the European standards, keeping the end in mind. From there, we have understood the data model, and we've partnered with some of the leading, I would say, domain experts in this area. And with that data model, we have come up with some unique methodologies for one, data capture, data processing, and then data analysis. So that's what mGreen sort of is all about. Initially, when we started, we were fortunate enough to do a project in Netherlands where we had to do close to about 60 buildings, schools really, and we used the conventional laser scanners to capture the data. But we realized that these are schools, so getting permission and then the logistics of having professional surveyors go there, survey the data, and then processing it was very time consuming and very expensive. And actually, we were not really dealing with design issues really here. When you talk about conventional laser scanning or conventional survey of the built environment, we have been using these technologies for design and design analysis and renovations and extension. But looking at the parameters that were required to be captured, both spatial and attribute information for the purpose of ESG, we realized that we were trying to overdo this. And that's when we came up with a very unique way using the time of flight technology. Today, if you look at some of these devices like an iPad or an iPhone, can capture information, using these, what we call the do-it-yourself model, right? We don't need heavy-duty kind of scanners and sensors to do that for you. So we experimented with that using a very lightweight which we call DIY model, where we had a client use their own devices and such as an iPad, capture their building, and by remotely program managing that, we were able to extract all the data, the bill of material, all the information that was required for us to then calculate, the embodied carbon. And analyze that, and also provide that rating for that particular building as per the NEN standards. So it was a hypothesis, but when we actually did that, we were able to prove that we were plus or minus of 5%, and we were able to save almost 60% of time. Number one. Number two, since it was a DIY model, we were also able to create an awareness with the asset owner, because now it was very inclusive for them to be for them to be participating in capturing the data themselves, and then set up a sort of a common data environment where they could upload the data, and we could actually process and provide them the analysis. It also created a lot of awareness. So this actually encouraged us to sort of formulate what's called mGreen today, and therefore we believe that it's uniquely positioned, which is a lightweight model. It's not heavy duty. It need not be from a design perspective, but it's a very pointed solution, a data solution that can help in analyzing the level of the embodied carbon in buildings today.
It's kind of fascinating to see how you went from a clear BIM model and realize along the way that there is potential for it to be developed into an ESG reporting together with your customers. One aspect that I'm interested in before we dive into the challenges and the hurdles about going to market with a product like this for a company like Magnasoft, were there any particular strategies or components that you had to integrate into your software in order to make sure that you're compliant with many of these regulations? Because when we think about ESG, I think about Excel tables and compliance, not necessarily about LiDAR scans and iPads.
Yeah, absolutely. If you look at there are two parts to this. One is the building itself, right, and the life cycle of the building, and second is the operations piece of the building. And today there are very clear guidelines from a compliance perspective on both sides, right? Now, to meet that, there is information that's required, data that's required on what kind of materials or elements were used to construct the building, and what were the materials used. So what kind of, and of course the volume and the quantity of these, for example, the kind of lighting, the kind of heat pumps. So if you were to divide this into an 80-20 rule, we'll realize that about 80% of the challenge in ESG comes from about 20% of these elements or building elements or building components, right? So the idea was to focus on that. And so secondly, if on the operations side, if you look at the energy consumption over a period of time, it's tangible, right? If by capturing this data using some of these technologies, and we were able to not only extract the features or elements that were required, but we also had certain techniques by which we were able to match the kind of material libraries and be able to provide that information to our client as to what material, which year was it, based on the date of installation, and we were able to arrive at broadly what the materials that we used. And when we sort of modeled that around the standards, and we analyzed that and compared that data, right, it was quite kind of close. So it was not like a one hat fits all. There were three different challenges that we had to face. If I get into details, there are three levels of data sets. One is, of course, what I'm talking about, the TOF is more on the interior side. Then also the exterior side, we had to also capture that, and we did that using remote sensing techniques without really going on the field, in a very cost-effective manner, using aerial imagery and a combination of aerial imagery and mobile LiDAR. And of course, the topographical or the green area around the building, which is very important. The tree cover, the green area, was again done using high-res aerial imagery. So we had to integrate all these three data sets, and then had to extract the data. And of course, we started with the end in mind. So we had the data model, and then based on that, we came up with a source data matrix where we decided as to what's a primary source, secondary source, and tertiary source. And so we put together this proprietary framework. And then a lot of automation also came into play because we really didn't want to do this manually, understanding that if it's let's say at a city level, how do we do at a macro level? So we were able to, the key thing was to sort of look at a combination of these processes and combination of the data sets that were required as inputs, and keep the cost really, really, really low, in order to make sure that that it becomes very sort of effective as a solution. So
it looks like there's been a significant amount of work involved in addressing every challenge, and in a sense also, you had to look ahead in order to know what you need to do before you could implement it and reach where you are. And looking at Alex right now, I'm sure he's very curious to look into the future.
Normally, when I think about the future of a given technology in the perspective of 5 to 10 years, I tend to be super excited about the technology itself. But this time, I can't stop by thinking that we are running out of time, that this 10 years to adopt this technology may be just too long. So what do you think about those future trends, the growth from that perspective?
yeah, yeah. No, I believe that today you're right. We're running out of time. There is the net zero, commitment, the Paris promise by 2050 to, to be net zero, and there is now a thrust on acceleration of assessment, and the technologies such as geospatial have been there. It's just that they've not been adopted properly by some of these sectors. It is only simplifying what we already have and using these technologies and data, which is going to be a key enabler, for decisions to be made as far as the net zero goals that have to be met by all of us globally, or the circular economy we are talking about, right? And I believe that once, and of course, compliance is driving this in a big way. So there's an early adopter phase. Some of these key real estate developers are using these technologies and able to produce the reports that are required for their businesses, for their governance, for their compliance, for their customers, for their investors today. And very soon you will see that the whole industry adopting this technology, the geospatial BIM and data, from spatial information, becoming sort of an integral part of this the ESG solution. And just like navigation today, getting from point A to point B, you don't realize all the tech that's gone into it. I believe that next 10 to 15 years, it's going to become where the geospatial just becomes a de facto enabler to provide the data, to provide the insights, to provide proper, decision making as far as decarbonization of buildings are concerned.
Bobbie, it's really impressive to see how many projects you've already completed, 1,500, and also to see what I really admire is the fact that you've been very, very focused on the real problem and not try to over-engineer it. We could have not wished for a better guest to kickstart this new Problem Solved series. It's been a really interesting episode for me. I can't believe that it's already 20 minutes since we started speaking. What I find impressive is the fact that it's addressed a clear problem, and it's also something that's very important in the global fight against climate change and ensuring that business continues tomorrow and life as we know it. Before we let you go, I do have one question for you, and it's also something that I'm personally really interested in. What is the one thing that you wish our industry, the geospatial industry, understood better about our customers?
I think we from the geospatial industries tend to be very passionate about our work in terms of technology or in terms of data, and being able to find real world problems, understanding the customer's pain points really is the most important thing. If you look at geospatial industry, it came from a very academic sort of a background. It comes from some rocket science and remote sensing, and now it is sort of embedded in our daily lives, right? I think there's still a lot of work to be done. If we can learn better from our customers is what business problem or what pain points can technology, geospatial technology and data really solve. We've got a whole bit of knowledge about all the technologies and all the possibilities using the technologies and the data, but connecting that with real world business problems is one thing I think we can learn better working with our customers, right? Spending a lot more time understanding the pain points. How deep is the problem? How big is the problem, right? What are the different ways that we can solve the problem? Are we overdoing it? Are we meeting their business requirements? And number one. Number two, there is no perfect solution out there. It's a process. It takes time. It's an ongoing job of the geospatial industry to constantly solve the problems that we see today, right? So I think that's one key takeaway I would say that we should have as the geospatial industry, is to understand the actual business problem that our customers are facing today, and not push them too much towards what we know.
Fully agree, Bobbie, on this one. Thanks for this fantastic insights. And thank you for joining us today. It was great to have you, and I think we've learned a lot. And also thank you to our listeners and viewers for tuning in. Remember to subscribe to this podcast, Problem Solved, the Geoawesome podcast. And I hope to see you in the next episodes for more geospatial stories and more geospatial innovation. So see you next time, and thanks everyone.